Today we're going to talk about thunderstorms and the conditions that you need to make a thunderstorm, and also we're going to talk about the different types of thunderstorms. I showed you my notes already. They kind of look like a web or like a concept map. And when I start these concept map notes, I always start with a title. So what do you think our title should be?
Thunderstorms.
Thunderstorms. And if you're going to make a concept map or a brain web, generally those titles go in the center. I'm going to put mine at top center. So thunderstorms, top center. We're going to separate the stuff that we're talking about today into two categories. The first category will be the conditions that are necessary. The conditions that are necessary. After we talk about the things that are necessary to make a thunderstorm, then we will be talking about the different types of thunderstorms. All right, so conditions that are necessary. There are three. The first thing that you need to make a thunderstorm, this one is pretty intuitive. If it's going to rain, what do you have to have?
Water.
Water was what I was looking for with this one. Some of those other things are going to come along later, but perhaps water is the most intuitive thing that you need to make a thunderstorm. We're going to use the word moisture. The more moisture an air mass has, the less dense it will be. And that will be important for our next idea here. So we're going to make a little note right underneath. Moist air, air with a high humidity, is less dense. Moist air is less dense. The higher the humidity, the less dense the air. We talked about that in chapter 11. The water molecules get in between the air molecules and they push the air molecules apart. So if you're just talking about the air molecules, the air is then less dense because those molecules are farther away from each other. So moist air is less dense. Another thing that you have to have for a thunderstorm to form is called the instability of the atmosphere. And I'm going to put this one almost over in the middle. Instability. This has to do with the temperatures that are involved of the different air masses and how the temperature of that air mass compares to its surroundings. So you have to have an unstable atmosphere. And we'll come back and add a couple more details to that after we add our third thing that we have to have. The third piece that we have to have a thunderstorm, and that's why I left this one for last, because this is the one that is probably the most important. Moisture is the most intuitive. This one is going to be the one that's the most important, and that is lifting. When you look at thunderstorm clouds, especially in the summer, you should notice that the stronger the thunderstorm, the higher those clouds tower into the sky. You can see this really well in photographs of places like Nebraska and Kansas because the landscape is very flat, so you can see those storms from really far away. The taller the clouds, the worse the storm. That comes from this idea of lifting. Lifting of air masses occurs from a few different things. If the air is warm, it will rise. We know that warm air rises because it's less dense. If it's humid, we know it will rise because it's less dense. So warm or humid air is less dense, so it rises. That's lifting. As it rises, the clouds grow. As the clouds grow, the storms become more severe. The taller the clouds, the worse the thunderstorm. Let's go back and add some details to instability, because instability has a lot to do with lifting or rising air. Instability occurs when you have temperature differences. When the temperature of one air mass is different than the temperature of the air mass next to it. If those temperature differences go away, then the lifting that occurs because of those temperature differences stops. So when the temperature of the air mass that's rising, when the temperature of the rising air becomes equal to the temperature of the surrounding air, lifting stops. If you have two air masses that are different in temperature, the warmer of those two air masses is going to rise. As it moves away from the surface of the Earth, what's going to happen to its temperature? As you go up in the troposphere, the temperature is way colder. So as that warm air rises, it's going to get colder. When it gets as cold as the surrounding air, then it stops rising. So then the lifting stops. Unstable atmospheres are ones where you still have that temperature difference, where one air mass is a different temperature than another air mass. One more note down here. If the temperature of the surrounding air remains cooler, then lifting continues. We can make a couple of connections within these three conditions. We know there's three things that you have to have for a thunderstorm to occur. You have to have moisture, you have to have lifting, and you have to have instability. But the moisture causes the lifting. Moisture is one thing that causes lifting. And so is instability. Instability and moisture both cause lifting of air. The lifting is what causes the clouds, which is what causes the storm. So if you don't have the moisture and the instability, that thunderstorm is not going to grow very tall. If it doesn't get very tall, it won't be a very severe storm. The taller the storm, the more severe the weather is. I think I'm going to erase just a little bit here in the middle, otherwise I won't have enough space for my types. Okay, types of thunderstorms. There are two main types of thunderstorms. One type of thunderstorms comes from different air masses, different types of air masses, different interactions of air masses with surroundings or with the environment. The other is the one you're probably more familiar with. That comes from fronts, so frontal thunderstorms. Those are the ones that come from cold fronts and warm fronts, which would be two specific air masses that interact with each other. Let's start with the air mass thunderstorms, the ones you are less familiar with. Those come from two geographic features, or two things that we have on our planet, neither of which we really have around here. You can get thunderstorms that occur as air masses move around mountains. These thunderstorms occur because as the air mass is going to travel over the mountain, it has to rise. Just because of the fact that the mountain is there and the mountain is tall. If the air is going to travel over the mountain, it has to rise. Air rises over mountains. And we know that if air rises, that's one of the things that you need to make a thunderstorm. This has a special name, by the way. Your book uses this term, orographic lifting. And the way that I remember what that term means is by looking at just the first part of the word, ore. O-R-E is what kind of ore? Metal, gold, things that we mine for. Generally, where do we mine for things? In the mountains. So that's how I remember what this is. Orographic lifting occurs when you have an air mass. I'm going to draw a cloud because that's the best way I can think of to draw an air mass. And you have mountains, and that air mass has to rise over the mountains. When air rises, you can get a thunderstorm. So the first kind of thunderstorm comes from an air mass rising over the mountains. The second kind of air mass thunderstorm occurs when you're next to the ocean and you have a sea breeze. Again, not something that we really have around here. Sea breezes occur because, and this we do know from chapter 11, land and water heat and cool differently. Land and water heat and cool differently. So if we were to draw a picture, we'll have some land, we'll have some water. Here's our ocean. We'll have the sun. We'll make it green because I don't have yellow. During the day, which of those two things is going to heat up faster? Yeah.
The land.
The land. So during the day, the land is going to heat up faster. That means that it's going to warm the air right above it. And what does warm air do? Rises. So the warm air rises over the land during the day. This is, I'm making it red, but we'll put warm here just so you know. And as it rises, what happens to its temperature? It cools down. And then what happens to the air? It falls. So then that air would sink over the water. This would be the cold or the cooler air. This cycle of convection goes with the idea of lifting. Anytime you have lifting, warm air rising, you have the potential for a thunderstorm. And we'll just put a little caption down here in case you don't remember what your picture is for. Air rises over land during the day. And anytime you have lifting, you have the potential for a thunderstorm. Okay, let's switch categories. The types of thunderstorms that we are more familiar with are frontal thunderstorms, because that is typically what we have here in the Midwest. Frontal thunderstorms occur when you have a cold air mass lifting a warm air mass. When cold air helps or causes warm air to rise. We had two pictures for cold front and warm front. You put them on your foldable last time. The cold front, you have a cold air mass pushing on a warm air mass, and then the warm air rises. Cold front pushes on the warm front, and the warm front rises. You also had a warm front where we had warm air coming up to cold air. And then because the warm air is less dense, it has to rise. So warm air overtakes cold air and then rises. Both of those have lifting. Both of those have warm air rising. Lifting is one of the main things you need for the thunderstorm. We're going to add one note down here at the bottom. Notice that the picture for the cold front has a steeper slope than the picture for the warm front. Because the cold front has a steeper slope, that means more lifting, which means worse weather. Let's see if we can squish that in here. Worse weather. The more lifting you have, the more severe that storm is going to be. Okay, that is it for your thunderstorm notes. Please make sure that you have read 13.1 by the time we get to our quiz.